I was working for another employer. I still do some contracting work for them, nights and weekends, maintaining this code base. It's about 80,000 to 100,000 lines of terrible PHP. All those best practices Laura was just talking about, none of them apply to this code base. We have no tests. We have really tightly coupled components. What do I mean by that? Can everyone see the code there? I'm sorry if you can't in the back. But when I say tightly coupled components, I mean tons of components that reference directly other components. So here's a good example of that. We have some sort of user repository, which I will assume is used for managing user objects. And we have a user controller, which is responsible for handling requests and calling the user repository. And a couple terrible things we can notice about this code is that the user repository, when you call the find user method, creates a new database connection. Every single time, it creates a new database connection. The user controller, every time we call get user, creates a new user repository object, which means we're going to create a new user repository object. We're going to create a new database connection. And then if later code calls user repository find user again, we're going to create another database object. And this is just a bad thing. There's no way to test either of these classes without having a real database connection. Because if you try and test user repository, you're going to end up instantiating a new database connection. It's just going to happen. It's right there. It says db equals new database, and there's no way to get around that. So the way to solve this is with a best practice called dependency injection. What does dependency injection mean? Very, very simply, dependency injection means that no component should create the other components that it depends on. So like we just saw before, the user repository object is creating a database object. It's directly instantiating the database object, and that's bad. Instead, what we want to do is have some sort of injector, which we'll talk about a little bit more, that injects the dependency into the consumer. So in our previous code, the user repository would be the consumer of a database dependency. Typically, your injector is going to be what we call a dependency injection container, and we'll look at those in a little bit, but it doesn't have to be. Dependency injection containers are not a necessary part of dependency injection. Dependency injection is best demonstrated with an example, I think. So I have a page controller class done two different ways. The top way is without dependency injection. The bottom way is using dependency injection. So what's bad about the first way that we're doing this page controller? Well, every time you build a new page controller, it's going to build a new repository object. And because repository objects have a dependency on a database object, we somehow have to thread that database object through into the repository. So we're giving the page controller a database so that it can hand it off and create a new user repository. Well, what happens if we want to take user repository and, say, make it a mock or a stub object for testing? Or we want to turn it into an abstract base class or an interface so that we can extend it and use different types of repositories with page controller. You end up having to find everywhere in the code that instantiates a new repository and change that code out. And that could be very wide sweeping changes. And if you have no tests, like the code base I'm talking about, those could be very dangerous changes. The other bad thing about it is we're passing that database object in. The page controller doesn't need a database object. It doesn't care. It only needs that database object so that it can instantiate a user repository object. If the user repository object was already instantiated, it wouldn't even know that the database object exists. So that second way of doing page controller, we're going to use dependency injection. Rather than letting the page controller instantiate the repository object itself, we're going to give it a pre-baked repository object. The page controller doesn't have to care how the repository object is built. It doesn't have to care if it's a new repository object that is just for it, or if it's the same repository object that every other piece of your code is using. It doesn't care if it's a mock repository object. It doesn't care if it's a base class that has been extended, if it's an interface. The page controller has been decoupled from the repository object. Questions so far? Cool. All right. So in the previous slide, the page controller was the consumer. The repository object was the dependency. So now we need to talk about that injector, something that wires these two things together. And typically what you're going to talk about in this case is a dependency injection container. dependency injection containers' only responsibility is to define how different objects and components are wired together. There are lots of them out there. I would suggest finding one you like, not writing your own. I like Pimple. It's really simple. It's about 50 lines of code. You can understand everything it's doing in about 2 minutes. There's no magic to it, which is one of the reasons I like it. But all dependency injection containers are going to provide you with similar functionality. They're just going to change kind of the syntax in which they provide that functionality. 4 different things that we're going to need from our dependency injection container in order to start using dependency injection in our legacy code base are parameters, shared objects, factory services, and factory callbacks. And we'll talk about what those look like. So like I said, I like Pimple. All my examples are in Pimple. But all the concepts should be easily applicable to any dependency injection container that's out there. So the first thing we need are going to be parameters. Parameters are just simple values. They can come from a config file. They can be defined somewhere. We're essentially just saying, dependency injection container, every now and then I'm going to ask you for a DB host value. And I want you to return to me localhost, what I've assigned up there. Same thing for username and password. Shared objects are objects where there should only be one of them for the whole code base. So you might have heard of the singleton pattern. Shared objects coming out of a dependency injection container are a way to have a pseudo singleton pattern without having to write any actual code that talks specifically about singletons in your code base. So a shared object service, as far as our dependency injection container is concerned, is nothing more than a function that returns a value. Oh, thank you. So in this case, we're defining a database value. We're going to define a function that gets passed the dependency injection container as part of its parameters. And we're going to say, return a new database value. And then we're going to use the dependency injection container to get some of those parameters that we had already defined. So this is one of the ways in which dependency injection containers allow you to not have to wire all these different values through other objects that don't care about them. This is a shared object. There's only going to be one database connection in our whole application. No matter how many times we ask the dependency injection container for a database, it's always going to return to us the same object. So when we say, give me a database, it's going to run that function. It's going to save the output of that function, which is a new database object. And from then on, every time we ask for a database, it's going to give us that same object. So it's not going to instantiate a new one every time. And we can see that with the user repository, also a shared object. When we ask for a new user repository object, it's going to first ask for a database object. If it doesn't have a database object, it'll instantiate it. If it does have it, it'll give us that same database object, give it to the user repository, and then save that user repository object for the next time we ask for a user repository. So singletons without having to write code that says this is a singleton. The other two concepts are factory services and factory callbacks. And they're similar, but there's a very subtle difference to them. A factory service, unlike a shared object, is a service where I want a new object every time I ask. So with a shared service, like the database, when I ask for the database object, it's going to give me the same database object every time. With a factory service, when I ask for a new user object, it's going to give me a new user object every single time. As far as Pimple syntax is concerned, that means we wrap our service definition inside of a factory method call so that Pimple knows every time we ask for a user, run this function and return the output of it, which is a new user. A factory callback is a slightly different beast. A factory callback, rather than running the function and returning the output, our dependency injection container is going to return the actual function itself. So in this case, I'm saying, here's a function that returns a new user object, but I don't want you to give me a new user object. I want you to give me the function that creates user objects. It's a very subtle difference, but it's a very important one because we're going to end up using factory callbacks a lot more than we use factory services when we start migrating our legacy code. Does everyone see what the difference is? Questions? Oop.
Yeah, so I guess where I'm a little bit lost is that, and maybe you'll go into this later, but with the callback
Correct, yes. So we'll see that in a couple slides. Rather than asking the dependency injection container for a new user object, we're going to ask it for a function that creates user objects for us. Any other questions? Cool. Oh, yes. So when you access the factory callback function? So when you ask Pimple for the user factory, it's going to return to you the function that you set. And we can see that function takes a name parameter. Yeah, so you'd have to know that this function has other parameters to it. And that's actually a very important thing. The function that it calls can take other parameters. And so I put that up there just so that we can see that. You don't have to have it, but it's going to be a function call. And you can just call it like any other function that takes parameters or doesn't take parameters. Yep. Okay. So with the new knowledge of dependency injection, I contend that it's possible to re-architect our legacy application so that you never instantiate an object inside your application code. All object instantiation is wrapped inside your dependency injection container. I also contend, as a corollary, that it's possible to architect that same application so that you never reference the dependency injection container from anywhere other than the dependency injection container. That seems like a lot of work. We have 100,000 lines of code to go through. We're instantiating objects all over the place. Why do we want to do this? Why do we care? There's a bunch of reasons. First one, testing, quality. It's much easier to test an object if you can write a unit test where you can really isolate that class and not have to pass actual objects that it depends on into it. Remember our user repository that always instantiates a database connection? If the user repository is instantiating that database connection itself, you can't write a test that doesn't also include the database. Does everyone see that? And databases, they're hard to set up, they slow your tests down, they're prone to failure, so you're going to get non-deterministic failures in your tests, which is a bad deal. So we want to be able to isolate the classes that we're testing to just that class, avoid external dependencies, and that's really easy to do when you can pass in the dependencies as mock objects rather than having the class that you're testing instantiate them themselves. Second important thing is maintenance. It's really easy to debug problems in object instantiation and creation when all your objects are being created in one place. You never have to ask, where did this user object come from? Did something over here create it and pass it over here? Did that place create it itself? Where did it come from? You know user objects are always created in one place. This is the place in the dependency injection container. If I need to know if that user object was created correctly, or if my database object is getting passed the correct host name, I have one place I can go to and know that that is the place where it came from. Extensibility we'll talk about in a little bit, but if we change how objects get instantiated, we only have one place to change them. So if user objects, which don't take any parameters to their constructor right now, suddenly need a database connection of their own, we don't have to find everywhere in the code that creates new user objects and wire through a database connection to them. We can just change the definition of how to create a user object in the dependency injection container, and that's the one place we have to change. Flexibility, dependency injection in general opens up some architecture decisions that you can make that would be much more difficult to implement when your objects are getting created willy-nilly all over the place. And we'll actually look at that a little bit later, but just remember that dependency injection makes different architectures easier to implement. So we know we want to do dependency injection. We know what dependency injection is. We need some way to go through this 100,000 line application and start migrating things over. We don't want to do it all at once, especially with no tests. We have a client that isn't paying us billable hours to refactor an entire code base. They want new functionality and bug fixes all the time. So we need to be able to do this slowly over time. And this is the method that I've come up with for moving this legacy architecture over to use dependency injection. So step number one, we need to pick the class that we are going to upfit for dependency injection and create a container factory method for that class, either as a shared object, like the database, or as an object factory like the user factory. Then we're going to go through the code. We're going to search for everywhere that says new, that class name, and we're going to replace that new instantiation with a call to the dependency injection container factory method. Then we're going to modify the class itself. We're going to move all the shared objects out of the methods and into the constructor. We're going to move all multiple object creations out of the methods that create them and wrap them in an anonymous function and move that to the constructor. And then finally, we're going to modify the constructor to take those dependencies and have them passed in rather than instantiating them themselves. And then we're going to repeat that for every single class. I'm a big code person, if you haven't noticed. I find it much more easy to follow examples than theory, so we're going to look at some actual code. We're going to start with our old friends user repository and user controller. Remember, user repository, every time we call find user, is creating a new database connection. It's creating a new user object. And every time user controller calls get user, it's creating a new user repository. I'm going to start with refactoring user repository. When you're picking kind of a place to start with this, what you want to look for is the smallest change possible that makes the biggest impact to your code. And I think a pretty big impact would be not instantiating a new database connection every single time we ask for a new user object. So step one, defining a container method or a factory service definition on our container. So a user repository, it's a shared object. We only want one user repository for the entire code base. So we're going to define it as a shared object, a simple function that returns a new user repository. Step two, find everywhere in the code that says new user repository and replace it with a call to the containers factory method instead. So here I'm doing that by going into the user controller, which was saying new user repository. And rather than saying repo equals new user repository, I'm going to say repo equals container, give me a user repository. I usually find global variables to be evil. They are evil, don't use them. For a lot of the same reasons as you shouldn't be directly instantiating a user repository in here. They tightly couple your code, they make it harder to test. But in this case, I'm willing to use a global because I'm recognizing that this is an intermediate step in a much larger process. By the time we're done with this process, that global's not going to be there anymore. But even with the global, we've already made an incremental improvement to this code. The user controller no longer cares how user repositories are constructed. If user repository has any dependencies of its own, user controller doesn't need to know about them. User controller doesn't care if it's getting the same user repository object every time it asks or a different one every time it asks. We've completely decoupled user repositories from the user controller. So an incremental change just by adding dependency, a method to the dependency injection container. So now we're going to start playing around with user repository itself. Step 3A, find all the shared objects that user repository is creating and move them up into the constructor. In this case, our find user method was creating a new database object every time it was called. We know we only want one database object for the entire application. So database objects are a shared object. We're going to move it out of find user and up into the constructor and let the constructor build that database object instead. Store it as a property on the user repository, and then find user just has to use that property instead of instantiating a database connection itself. So again, incremental improvement. Just changing this small thing has made this code so much better because we're no longer creating a new database connection every time we call find user. Find user doesn't have to care how database objects are created anymore. So database object takes some connection parameters that find user doesn't need to know about anymore. Now the slightly trickier one. Unlike database object, which is a shared object that we're going to want all of our application to use the same database object, we do want find user to create a new user object every time it gets called. So we can't just say this user equals new user in the constructor. Instead, we're going to wrap that new user call in a function that creates users. Everyone see that? And then in find user, we're just going to call that function. I wish there were a prettier syntax in PHP for calling random callables, but that's as pretty as it gets. But we've already made this code better as well, because now find user doesn't have to care how user objects are created. It can get a new user object every time. In fact, it doesn't even care if it gets a new user object every time. It's just going to call a function that it knows gives it back user objects. It could be the same user object. It could be a different user object. Find user doesn't care. So this is the first time we actually get into actual dependency injection. We're way down in step 4, and now we're going to do some actual dependency injection. Database object, again, shared object. We're going to make a shared object service for it on our container. So we're going to define a function that returns a new database. And then we're going to modify our existing service definition for user repositories to pass in the database object. Lastly, we're going to go into the constructor of the user repository. And rather than having the constructor create a new database object itself, we're going to say, you're just going to be given a database object. Use that, wherever it came from. This is probably the biggest improvement we've made in the code so far, because now user repository isn't responsible for creating database objects anymore. Doesn't care where they came from, doesn't care if it's the same one or a different one, doesn't care what database's own dependencies are. We can start testing user repository using a mock database object rather than using a real database connection. So let's go to the next step. Rather than having user repository define the user factory, we're going to put the definition of the user factory into the dependency injection container. So this is the case of a factory callback rather than a factory service. We don't want user factory in the container to give us new user objects. We want it to give us a function, a callable function, that returns new user objects. And then we can tell user repository, you're going to be given a callable to create user objects. You don't know if it's going to be a function. It could be an object that implements the magic invoke method if you're using PHP 5.4. Just here's the function you should call to create new user objects. Just as a side note, that callable keyword, if you're not using PHP 5.4, just leave that callable keyword off. It's only available in 5.4 and above. But everything else should be applicable here. So at this point, we're done. User repository is now completely decoupled from database objects and user objects. It doesn't care how they're created, doesn't care where they came from, doesn't care if they're real or mocks for testing, doesn't care what their own dependencies are. We've completely removed the responsibility of user repository from creating databases and users. We don't see the new keyword anymore. We don't see any references to the dependency injection container itself. So we're done with user repository. Does everyone see how we got from beginning to end? Questions? Oop.
In this example, what's the benefit of returning a callable versus a
So find user, every time we call it, we want to get a new user object out of find user, right? So we're going to give find user a user ID and say, hey, database, select whatever from the users table with this ID. And every time we call that, we could be calling it with a different ID every time. So we don't want to return the same user object for every ID we pass in. We know that we're going to need a new user object depending on what the ID is. So rather than passing in a user object to user repository and saying, here's the one user object that you always return, we're passing in a function that says, give me a new user object, then let me set its properties or manipulate it however I want, and return that new user object. So we need something that creates user objects as opposed to a user object itself. Cool. Other questions? Yes?
How is the scale of a legacy class that might have dozens of different objects instantiating?
If all you're doing is following this method and not going a step further, yes. I can promise you it will, because I've definitely, in the legacy application I'm talking about, that has ended up being the case in a lot of cases. So once you get that far, remember I mentioned before, dependency injection kind of opens up a lot of flexible architecture decisions. One of them is the ability to start refactoring those types of classes. If you have an object that has dozens and dozens of dependencies, that object is probably doing too much. Probably needs to be broken down into smaller objects that do fewer things, and then that object that has the dozens and dozens of dependencies can just be passed the 3 or 4 that each have their own dependencies and do it on its own. Typically, when you have a class with dozens and dozens of dependencies like that, it's because it's not using all those dependencies itself, it's wiring them through to other things that it depends on. And this is one way to get around that. So this process isn't complete. There's still more you can do, but it makes it easier to start doing that when you move things in this direction. Cool. Good question. So now we're going to repeat the process for user controller. I promise you I'm not going to go slide by slide on this. I'm just going to show you where we started and where we ended. The last time we looked at user controller, we had that ugly global that was asking for a user repository out of our container. Now we can just define a shared object for a user controller. We probably only want one user controller in our application. And it's going to use the dependency injection container to get a user repository that it depends on. And we're going to pass that user repository into the user controller rather than letting the user controller instantiate its own or have to get a user repository inside get user from the global dependency injection container. So at this point, user controller, we don't see the new keyword anymore. It's not instantiating any objects on its own. And we've gotten rid of all the references to the container, which was kind of my secondary goal, was to not have to reference the dependency container anywhere else in the application. So we've gotten rid of that as well. So now, again, same benefits. User repository, when we're testing user controller, could be a mock object. We don't have to instantiate new databases for it. We can change the dependencies that user repository has without having to change those dependencies inside of user controller, so they can vary independently of each other. So that seems like a lot of work, and it is. It also seems like a lot of steps. That's a really long, arduous process. I mean, I just showed you a slide where that's where I'm starting and that's where I'm ending. Why can't I just jump to that? Why do I have to go through all those intermediate steps? Quite honestly, I'm not, and I know probably you're not, going to sit down and refactor 100,000, a 200,000, or even a 50,000 line code base in one go. It's just not going to happen. That's a lot of code to have to comb through. We don't have tests to guide you. You're going to break a lot of stuff, so you want to make sure you're going slowly so that you can test after each step. Very important to test after each step of this process. Even if it's just end user testing, I'm refreshing the page in the browser to make sure it comes up. If you work on a product team, your product manager is not paying you to sit around and refactor code. He's paying you to build new features. Your clients aren't paying you billable hours to sit around and do this for hours and hours on end. So the reason there's so many steps in this process and the reason they're all important is because each one of them is discrete and testable. You can go through them step by step, and if you stop at step 3 and never get to step 4, you've still improved your code. You've made incremental changes, and you can test those changes without having to go through step 4. You can put the process down for a week or a month or however long and come back to it later and know that your code has been improved and it's waiting for you to pick up the process when you're done. So one of the things that drove me to start doing this to this legacy application was about a year and a half ago, I got a whole slew of new requirements for this application. For about 5 years, it was in maintenance mode, just bug fixing. And then suddenly, the HR department at the company changed to a new HR system. We had to integrate with a bunch of new things. And here's a bunch of changes that need to be made to this legacy system that's been chugging along since 2005. And it would have been impossible. I mean, the code was just not in a state that would have allowed us to easily integrate some of these new features. So an example of one of these new features is every time a user submits some report, send an email. And that's just one new feature in a stack of things that are similar to that. Every time a user does something, do some other set of events. Send an email, increment a counter, create a new PDF out of a file. A bunch of independent steps that all need to happen based off of one event happening. So I made the executive decision that this sounded like a good use of the observer pattern or the pub/sub pattern, publish and subscribe. We have an event that's happening, and we want to do some set of independent actions based off that event happening. When I was creating user objects everywhere in the code, that would have been really difficult, because suddenly I have to find each of those places where a user object's being created and pass in all the dependencies that are necessary for sending an email when a report is sent, or incrementing a counter, or creating a new PDF, or doing all those various things. With dependency injection, it's actually fairly easy to set up the users to do that. We have some event emitter. It's just a message bus, basically. We tell it on one end, hey, new report created. It tells everything else that's listening for new reports. A new report was created. Here's the user. Here's the report. So we're going to inject our event emitter into our user object. And then down at the bottom, we're going to update our user factory to pass in that event emitter. Extensibility was one of the things I put on the why bother slide. This is why bother. Rather than having to find every place in the code that a new user is created, this is the one place in the code that new users are created. This is the one place that has to change. We're defining a couple more shared objects, an event emitter, and an email service for sending emails. I'm simplifying here. User object gets the event emitter, and then we know that when new report objects or events are emitted, we want to send an email of some kind. Without dependency injection, we would have to always instantiate a new email service and always subscribe it to listen for new reports. Because even if we're not going to be sending reports or even creating user objects, because we don't know when user objects could be created. They could be created any one of 1,000 places. So we always have to instantiate an email service and always have to subscribe it to listen for new reports. Here, we only have to subscribe the email service when we know users are being created. So we're saving resources, we're saving application bootstrapping time, we're making things less complex because we don't have to subscribe to things that will never happen. We know if we're creating a new user object, it's fairly likely users could be sending reports, subscribe the email service to listen for new report events at the place where users are being created. So this code base, getting better slowly. I haven't done this everywhere in the code. There's still a lot of really ugly bits, but I have unit tests for the first time in that code base. That's really cool. And it's getting easier to work with. The client, when I was working on this, didn't see a lot of benefit before to me spending their time and money doing this to the code. But now they're seeing that benefit, and I can start providing some of these features much faster because I'm not worried about how things are all intertwined. I can just worry about here's where this feature goes, here's the things that have to change for it. So they're happy about that. So yeah, things are getting better. Dependency injection is one of the major reasons why those things are getting better. And I really hope that I've convinced you that dependency injection is a good idea and given you a process that you can now take back to your own legacy code or even your own new code and start to use some of these practices and principles and make your code better, because better code is better for everybody. So good questions during, I told you I'm a code guy. Good questions during stuff. Does anyone have any additional questions? Does anyone think I'm just off the ball completely? Yes?
I guess I've looked at things like this, especially like single pattern and stuff like that before, and it seems to me like I understand what you're saying, that if you're calling, if you're instantiating the same place all the time, into that constructor and such when you're
sure. So let's look at an example. Somewhere in one of my slides, I had this thing. Okay, so let's look at the user factory callback right there, right? We're returning a function that creates users. And one of the things that that function can take is a name that we could pass to the user constructor, right? So a name or some other thing that is going to be different for every user is something that we could pass into the factory callback and have the factory callback function take those parameters. But for something like the database connection or that event emitter object that we created, that's going to be the same one every time. So you can actually mix and match inside of this function. You could have some of the user's constructor parameters come from the dependency injection container, and some of them come from being passed into this factory callback. So in the case of users suddenly take a name and they didn't take one before, then in that case, yeah, you'd have to go and you'd have to find everywhere that a name is being passed in and thread that through. But likely, if you're passing a name to a new user object, you're passing it to the thing that's creating that user object as well. So like, say our find user method we had before that was passing an ID every time, that ID is probably going to get passed into the user object, and it's going to be different for every user object. But there's some stuff that's going to be shared amongst every single user object. And so the shared things can come from the dependency injection container. The kind of one-off things that change every time you need a new object, those can be passed in because they're part of they're part of the, I don't know how to phrase this. They're part of the usage of that object, but not necessarily its creation.